All right, let's go over the answers to those exponential growth problems that we did for section 7.8. So first one, during a chemical reaction, the rate of change of the amount of the chemical remaining is proportional to the amount remaining. So a really important word that tells us what we're dealing with here is proportional. So I'm going to use Y for the amount of the chemical. So we know the rate of change of the amount. So that's dy dt is proportional to the amount remaining. So this is our differential equation that we're dealing with. Pretty much all of the questions in this section are these. So at time t equals 0, the amount is 12. So that's super convenient when they give you a value for the initial time, so t equals 0. So they give us C with that. At time t equals 4, the amount is 4 moles. At what time t is the amount of the chemical 3 moles? So we need now an equation that deals with just the amount at any given time. So we need an equation for y of t. So we know that when we're dealing with this, we're dealing with exponential growth. So these differential equations that are proportional to the amount, we're dealing with this formula here. So what we need to find here, we already know that 12 is C. Reason for that is because when t is 0, no matter what C is, when you plug t in as 0, you're going to get this will turn into 1 because e to the 0th power is 1, and then C is whatever that y value is. So C is 12 in this case. And they're telling us that when t is 4, y is 4. So this is what we know so far. So C equals 12 e to the kt. So we need to find k. And we can do that using t is 4 and y is 4. So where can I save it? Let's go to the next page here. So we know 4 equals 12e to the 4 times k, and we need to find k. So if we divide by 12 on both sides, 4 divided by 12 is 1/3. So 1/3 equals e to the 4k power. In order to get that k alone, we need to take the natural log of both sides. So when we do that on this left-hand side over here, I want to rewrite this so we don't have a fraction inside the natural log. So we'll expand it like this. So something nice happens over here. So we have natural log of 1 minus natural log of 3. Natural log of 1 is just 0, so that goes away. So now we're just left with negative natural log of 3 equals 4 times k. Divide by 4 on both sides, and k equals negative natural log of 3 over 4. All right, so let's go back to our question. So we now know that k equals, so k equals a negative natural log of 3 over 4. All right, so now that we have that, we have pretty much everything we need. We know that c is 12. We know that k is this right here, so we can now find t when y equals 3. So let's go over here and do that. So y equals 12e to the kt, where k equals negative natural log of 3 over 4. I'm not going to write that every time just because it's a lot of writing. So we'll leave it as k until the very end. So y is 3. Divide by 12 on both sides, and we get 3 divided by 12 is 1/4. Then to get the t alone, we need to take the natural log of both sides. And we're going to do that same thing over here. Natural log of 1 minus natural log of 4. That turns into just negative natural log of 4 equals k times t. So then divide by k on both sides, and we get t equals negative natural log of 4 over negative natural log of 3 divided by 4, which equals, so that 4 is going to come up to the numerator. We'll have 4 natural log of 4 over natural log of 3, and it's positive because we had a negative divided by negative. So we go back to our original question, and that is letter D. All right, next one. Kitten weighs 85 grams at birth. During the first 4 weeks, its weight is given by the function W that satisfies the differential equation here. dW over dt equals k times W, where t is measured in days and k is some positive constant. Which of the following could be an expression? So the idea here is that you want to recognize that when you have a differential equation in this form, its general solution is W equals C e to the k t, and there's only one that's in that form, and that's letter D. But before we completely move on from that, let's just review why it's in that form. Getting ahead of myself. So dW over dt equals k times W. Let's review how we get it into this form. So we're going to use separation of variables. So what I just did here was I divided by W on both sides to get 1 over W. And then I multiplied by dt on both sides. Now I'm going to integrate both sides. We know the antiderivative of 1 over W is natural log of the absolute value of W. And the antiderivative of k dt, since k is just a constant, it's kt plus c. To get the W alone, do this. So W equals e to the kt times e to the c. I'm just using an exponent rule. Since we have addition in the exponent, we can rewrite it like this. And since c is just an arbitrary constant, e to the c is also an arbitrary constant, so we can just call it c, another c. So that's how we get W equals c times e to the kt. So again, you can just skip right to that, but in the event that you forget when you have an equation like this, you can figure it out. So don't be too freaked out by memorizing it, because if you forget, it's not the end of the world. All right, so this one requires some work. So extreme heat applied to a colony of microorganisms causes the size to decrease according to the exponential decay model right here. So not mean to zoom in. So this one right here actually gives us something really important. So they're actually giving us K. So that's very helpful. We don't have to find it. And then we have a second one that decreases according to this model. So that's actually a totally different model. That's not it's not proportional to anything. It's just a linear model. So if at time t equals 0, the first colony, p of 0 equals 2, and the second colony has a size q of 0 equals 3, at what time will both colonies have the same size? All right, so what we want here, we want to know at what time p of t equals q of t. So the key here is to find functions for both p of t and q of t. So we know that dp dt equals negative 0.4p, and we know that p of 0 equals 2. So since this is in this form, we know that p equals c e to the k times t is our general solution. And since they give us this. Like I said in the first problem, if they give you t equals 0, that means that value is your c value. But now let's refresh our memories on why that happens. I know I said it, but just to really drive that point home. So if p equals 2, we have ce to the k times 0, which is 0. Anything to the 0th power is 1. So we're just left with 2 equals c. So really quick, that's why whenever we're dealing with this formula, t equals 0, the function value is c. Okay, so we've got that. So that means p of t, we actually have everything we need. So p of t equals c e to the k t. So that's p of t, because again, I said that this gives us k right here. So now we need to find q of t. So let's erase. So we've got this. Let's erase now to get q of t. So that one was a linear model. So keep that in mind when you're integrating, because if you don't end up with something, a linear function, then that means you did something wrong. So it's a linear model because dq over dt equals -1. So the rate of change is constant. Think about it. Linear model, a line has a constant slope, doesn't it? So if the rate of change is constant, then of course it's going to be a linear model. So for this, when we do separation of variables, we have dq equals -1 times dt. Integrate both sides. You're left with q equals -t plus c. Great, that's definitely a linear model. It's got a slope of -1. That's perfect. So now we just need to know c. We were told that q of 0 equals 3. So that gives us the initial condition, which is c, but let's just prove why that's the case. So q is 3 when t is 0. Pretty clear why c is 3 in this case. So that means our function q of t equals -t plus 3. Great. Let's go back to the question. So we know p of t, we know q of t. We want to know when they're equal. So let's write it out just so we know what we're looking at. So p of t is 2e to the -0.4t equals q, which is -t plus 3. All right, so fortunately this is a calculator question. So let's take out our calculators, go to y equals. I already have them typed in here. So type in your two functions, make sure your window's looking okay. So the way I know it's okay is they give me multiple choice options here, so I want to make sure my window covers everything we're dealing with here. So these are x values. So my x min is -10, my x max is 10. That's much bigger than I even need it to be. So it covers everything in here. Then we graph. We want to see where these functions are the same. So that means we need to see where they intersect. So they're slowly graphing. All right, so this intersects in two spots. Now we're talking about population. We do not want, actually scratch that. Scratch that, we're talking about time. We are talking about population, but our answers here are time. But same idea, same thing I was gonna say. So we're talking about time, we do not want negative time. So we want the positive place where they intersect, so the positive x value, which is this one right here. So we go to second, and we don't go to second. We do go to second. Second, calc. That's it. All right, and then we do number 5, intersect. We go here, about where they intersect, hit enter, hit enter, hit enter. There's our answer. So x equals 2.156, which is letter C. All right, and we move on to number 4. So number 4 has a lot of work involved with it. All right, so during optimal conditions, the rate of change of the population of a certain organism is proportional to the population at time t in hours. Okay, let's see. So let's use P for population. So dP dt equals K times P. At time t equals 0, population is 300. So again, we're dealing with y equals c e to the k t, where c is 300. At time t equals 24, population is 1,000. At what time t is the population 500? Okay, so we need to find, first, let's find k. So y equals, let's go to the next page for room. So y equals 300 e to the k t, and y is 1,000, and we want to find k, and t is 24. Okay, perfect. Oops, that should be a k. All right, so we need to solve this. So first we divide by 300 on both sides. So if we divide by 300, we get 10 over 3 equals e to the 24k. Take the natural log of both sides. Divide by 24, and you get natural log of 10 over 3 divided by 24. Now, some of you might be wondering, why didn't I split this up using subtraction like I did before? My answer to you is that my multiple choice options have fractions in the natural logs, so I'm not going to do extra work. I'm going to leave it like that because that's what they seem to do. All right, so we know K. We now need to find T when population is 500. So let's see if we can squeeze this in here. So now we know K, we know C, so K equals a natural log 10 over 3 all over 24. And we're dealing with y equals 300 e to the kt. And what's the population? 500. We want to find t. All right. So we divide by 300. We get 5 over 3. Take the natural log of both sides. We get natural log 5 over 3 equals k times t. To get t alone, we divide by k. So t equals natural log of 5/3 over natural log of 10/3 over 24, which is the same thing as B. So that's it for number 4. Number 5, fortunately, not a lot of work to show for this one. So a dose of 400 milligrams of a drug is administered to a patient. The amount of the drug in milligrams in the person's bloodstream is given by A of t. The rate at which the drug leaves the bloodstream can be modeled by dA over dt equals k times A. Which of the following could be an expression for A of t? So dA over dt equals Ka. So since it's in that form, we know that we're dealing with A of t equals C e to the k t. So also, side note, C e to the kt, we actually know what C is in this case. C is 400 because when t equals 0, they have 400 milligrams in their bloodstream. So that leaves us with A as the best option here. Even if you didn't make that connection that 400 is C, that's still the only good option because it's the only one in that form. So that's number 5. It's just another one recognizing what type of equation we're dealing with here, what the solution of this differential equation would look like. General solution is going to be exponential. And again, like we did in one of the earlier problems, you can figure that out using separation of variables variables, but if you can just recognize it, then you're fine. All right, last one. We've got a radioactive substance. The quantity of it decreases according to the exponential decay model right here. During an experiment, the scientist determines that the rate of decay of a second substance can be represented by a linear model. So this is looking a lot like that other problem that we did, where t is measured in seconds. So this is really, really similar to that other one we did. So dr dt equals this, which tells us that k is negative 0.05. And we know that C for that is going to be 100 because they give us when t equals 0, r equals 100. So now we know pretty much everything we need. So r of t equals c e to the k t power. And that's that. For the second one, we've got a linear model again, so I don't think I need to show you again the integration to find that because it's a linear model, a constant slope, so it's going to be a linear equation. So ds dt is negative 4, which means our slope is negative 4. So s of t equals negative 4t plus c, which is 125. So again, if you want to look at the separation of variables, go back to the last question that was like this. I think it was number 3. Yes, it was number 3. So go back to number 3 and look at that. Or you can just sort of reason through it like I did just then. It's a linear model, so it means it needs to be a linear equation. Slope is negative 4. And then the y-intercept actually would be 125. So this is just regular old y equals mx plus b slope-intercept. And now we have our two equations. So we want to do the same thing, where we want to know when they equal each other. So when does r of t equal s of t? Well, let's go back to our calculator because this is a calculator question. Go to y equals. Change these out. So this is going to be 100 e to the negative 0.05 times x down, and this is going to be negative 4x plus 125. All right, then we graph them. So we've got like a wide range going on here. 2 of them are in the window that I have. So remember, my window goes from x equals negative 10 to x equals 10. The 2 of these fall in there, so let's just check and see if that works first. It's not looking too good, is it? So we don't even see our equations in there. So let's go back to our window. Still graphing. There we go. All right, so we're back at our window. So obviously C and D are not my answers because the graphs didn't even fall in that range. So let's make this a little bigger. So I want to go up to x equals 50. I want to go to 50 because that should cover my other 2 options. Okay, so also not looking great. Looks to me, I see a little blue line here, I see a red line here. So kind of looks like they might be intersecting a little further up. So let's adjust again. No big deal. So we'll go down to our y max. Let's make that a little higher. Sometimes this is how you have to do it. You just guess and check. So now let's graph. Okay, so we can definitely see more of that function. Okay, perfect. We can see where they intersect now. So let's figure that out. So number 5, go this way. Okay, great. So we intersect at 23.548, which is letter B, which is the correct answer. So that's it for the 7-8 exponential growth questions.